adding with 1 electron. Now you are going to get O minus 1. Okay. In this case, delta H is always will be negative. Exothermic process. Okay. It is an exothermic process. And if I take what next? O minus 1. O minus 1. Taking the second electron, one more electron, that is converting into O minus 2. Here delta H is equal to what I said here? Positive. And it will be endothermic reaction. It will be endothermic reaction. Yes. Now this one will be first electron affinity. EA1 I am writing. First electron affinity. This one is what? Second electron affinity. Electron affinity, second it is. First electron affinity, second electron affinity. Okay. Now always the second electron affinity always will be what actually? Endothermic process. If you see any second electron affinity or third after the second, from second electron affinity onwards, they're all what? Endothermic reactions. That means heat will be absorbed. Heat will be absorbed. And 99% of first electron affinities will be what? 99% of first electron affinity will be what? Exothermic process. That means when you add first electron, heat will be liberated. Exothermic. When you add second, third, fourth electrons, what happens? You have to supply the heat. Why? The reason I explained yesterday only, to overcome the repulsions between the electron and the negative charge. To overcome the repulsions present between the negative charge and electron, we need to supply some energy. So this is about the definition we just discussed in the last class. Okay. Now let me see here the continuation topic here. Continuation to this one. सारी चीज हमने yesterday आपको बताया मैंने. Second electron affinity means adding second electron here. Simple thing. Okay, everything will complete it. Now let me see in the trends what happens in the groups and the periods here. Electron gain enthalpy or electron affinity, both are actually same in periods and groups. Let me see this one. In period, what happens? When you observe left to right in period, electron affinity will be always increases here. They always what happen? Increases as we move from left to what? Right across the period actually. For example, we'll take a beautiful example here. Lithium, isn't it? I'm taking an example here. A very good example I'm taking here. Lithium. Then after that, which element will come better? Beryllium. Which period is? Second period. Second period, boron, carbon, nitrogen, oxygen, fluorine, neon. So these are belongs to second period elements, right? Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, all belongs to which period? Second period. Now what they are saying, rule is what? Left to right. Left to right, electron affinity values, what happen here? EA, electron affinity values will increases. This is the thing. What is the reason? See, nuclear force of attractions will increases here. So reason is because of nuclear forces of attractions are increasing here. You observe here what happened? This is the thing. Effective nuclear charge increases, nuclear force of attractions are increasing here. Right? Now here, one thing is very important. Neon, which is the last element, whose electron affinity is what? 0. That is the reason, isn't it? These group elements are called zero group elements. Why these group elements? Which group? Group 18. This group 18 elements called zero group elements because their electron affinity is what? 0. So if you want what electron affinity values of neon, definitely it will be positive value because it does not want electrons, because they're having octet configuration. They don't want actually electrons actually. So that is the reason I told you 99% first electron affinities will be negative, but remaining 1% will be like zero group elements, like nitrogen, they are having delta H equal to positive because they don't have the reactivity. Whichever the elements are not having the reactivity, which are inert, isn't it? They are having zero electron affinity values. If you want to add electron, you have to supply the energy. Understood my topic here, what I said here? Now you have to see from lithium to beryllium, beryllium to boron, carbon to nitrogen, nitrogen to oxygen, oxygen to fluorine. What happened? Electron affinity. That means up to 17th group. For example, if I take what 13th, 14th, 15th, 16th, 17th, 18th, 19th group. Now left to right up to fluorine it will increases, but zero group element, group 18, isn't it? Sorry, what I got here? Sorry. Just a minute. You got here? Okay, sorry. Just a minute. Here it is. We got 19 here. Just a minute. Sorry, here it will be first group. Okay, second group, 13th group, 14th group, 15th group, 16th group, 17th group. Okay, now here I told you the group 18 will have 0. Now lithium to fluorine, electron affinity values will be increases here. But one exception here also is the nitrogen. Nitrogen is having electron affinity is positive value, less value, less and positive also. Why? What is the reason? Because of half fill configuration. Okay, if you want to add electron to nitrogen, does it lose a half fill configuration or not? Tell me. If you add electron to nitrogen, does it lose half fill configuration?
Yes, sir.
So nobody want to lose half fill configuration, completely fill configuration. So that is the reason when you observe nitrogen will have what? Some positive values. So its electron affinity is what? Very less. Even compare with carbon also. So one exception you have to observe here where nitrogen, and obviously what happened? All zero group elements. All zero group elements. Remaining will be what happened? Increases. So this is the thing actually. Okay. Next, for example, you take this one. Now here, if you observe here what happened, this is the chlorine atom, right? This is the chlorine atom. Now we are adding an electron to what here? Chlorine. Okay. Now how much amount of energy released here? 349 kilojoules of heat is liberating here. So when you add electron, what happened? Heat is liberating like this, isn't it? So this is about actually what? For example, you take oxygen, you're adding an electron to oxygen here. So heat is here also what happened? Released here. So what I mean to say is that one addition of one electron, first electron is always what happened? Exothermic process. But when you add second electron, now you are adding second electron over here. Which electron you are adding? Second electron. Now you are absorbing the heat. Now heat should be supplied. Understood here? When you take first electron, isn't it? When you take first electron, what happened? Heat is what happened? Releasing. But when you take the second electron, what is happening here? Heat is what happened? Absorbing here. So for first electron, this much amount of heat is liberated here. For second electron, this much amount of heat is absorbed. Already we discussed this one, but in the diagram. Now in groups, what happened? Electron gain enthalpy decreases, opposite. For example, in the period, if it increases, definitely in the group, it will decreases, opposite it will. Now it will decreases now, the electron affinity values as we move from top to bottom here. Okay. Reason what happened? Size will decrease. So what happened? That top to bottom, the size what happened? Increasing? No. When size increases, what happened? The effective nuclear force of attractions will what happened? Decreases. So the period what happened? Effective nuclear charge increases, electron gain enthalpy increases, wherein the group what happened? Effective nuclear charge decreases and the electron gain enthalpy also decreases. We'll see some example here. We'll take some example here. Okay. Now, if I say what happened, I'm writing here also. Okay, first of all, I'm writing what actually here I'm writing. Better to write here. Group 16, group 17, let me take group 17. Okay, now fluorine, bromine, iodine. Remaining I am not taking because remaining are which elements? Radioactive elements. So they are not, their properties are completely different. The properties are radioactive properties. They are different. I am not taking. Only 4 elements I am taking. Group 17, fluorine, chlorine, bromine, iodine. Now, top to bottom, atomic size increasing, atomic size increasing, effective nuclear charge, what happened? Also what happened? Here is decreasing. Atomic size increasing, effective nuclear charge what happened? Decreasing here. Now electron gain enthalpy, electron affinity value should also what happen? Decrease. So the order must be like this: fluorine greater than chlorine, bromine, and iodine. This will be the, isn't it? Expected value, correct or not? Expected. This is expected electron affinity values. Expected electron affinity values. What are these? Fluorine is more than chlorine, chlorine is more than bromine, and iodine. But this is wrong actually. So exception is what actually? What is the exception here? Now, actually observed, if you observe, chlorine is greater than fluorine, fluorine is greater than bromine, bromine is greater than iodine. This is observed actually. So where we are getting some difference here? Here it is. Here it is no problem. Here it is correct only. But here you are getting difference. Actually, fluorine should have high electron affinity. But which is having more electron affinity? Chlorine is having more electron affinities, isn't it? This thing is very, very important. Now let me see what is the reason behind this one. All of you please note down this one. Note down this one. Let me see the reason. We come next one. Let me see the reason actually. What is the reason behind this one? What is the reason? Now, when you observe what happened here, now in electron affinity, if you observe fluorine and the chlorine, okay. Now, here you are adding an electron, okay, and here also you are adding an electron. You are getting what? F minus here, and you are getting a Cl minus here. Now, this is called what? Electron affinity, right? EA1, electron affinity 1. Electron affinity 1. Now I am saying here the value is what? Less. Here value is more. Electron affinity is what? More for this one. More. Delta H minus X is more here. Where delta H minus X is what? Less. So reason behind this one. See. Fluorine is small size or not? Tell me. The size of the fluorine is small or not? Correct or not? Which is having more size, fluorine or chlorine?
Chlorine, sir.
Chlorine, sir.
So when you are adding electron, isn't it? There will be some repulsions present here. There will be some repulsions will generate here because fluorine is what? Very small size. So because of this, what happens? Small size, repulsions are generated. Because of the repulsions, what happened? Electron slowly adds to the fluorine. Okay, the addition of electron with fluorine, what happened? Not easy for us. But in the chlorine, because of more size, presence of d orbital, there is a d orbital is there, but empty d orbital is. If you observe what happened in the fluorine, we don't have the d orbitals because the configuration is what? 1s2, 2s2, 2p5 it is. Therefore, we don't have any d orbital. But in this case, 1s2, 2s2, 2p6, 3s2, 3p5 and 3d 0 it is. There is empty d orbital and size also more here. So when size is more, what happened? The electron easily will add here. So repulsions, what happened? Very less. The repulsions are minimized because of what? Empty d orbitals. The repulsions are minimized because of more size actually. So this is the reason actually chlorine is having more electron affinity. You can say what happened? Bromine is having more size, no. But in that case, what happened? The effective nuclear charge, what happened? Dominating in that case. So in the case of these two, what happened? Size is dominating. In these two cases, what happened? Effective nuclear charge is dominating. So in examination, surely you will get a question from this chapter. What is the chapter? Why chlorine is having more electron affinity than the and presence of empty d orbital, the repulsions generated can be minimized. Therefore, what happened? It has more electron affinity values. आपको एक ही कीवर्ड याद करना है, वो क्या है? मोर साइज, मोर साइज. If you remember this keyword, what happened? You can write what happened in the sentence formation. Because of size is more on the chlorine, it has more electron affinity values. Similarly, when you observe the group 16 here, group 16, if you observe what happened, oxygen, sulfur, selenium, and the tellurium, if you observe what happened. In this case, what happened? Here also same thing is happening. Sulfur is greater than selenium, selenium is greater than tellurium, and oxygen is having low electron affinity values. Low electron, isn't it? Because of very, very small size, isn't it? This is happening like this. And sulfur is having more. So when you observe here, this is the order for group 17. ये आपको याद रखना है. This is for group 17 and this is for what? Group 16. ये दोनों आपको याद रखना है. Group 16. Lesser than sulfur or sulfur is having more than oxygen. Same explanation आपको करना है. कौन सा explanation करना है आपको? Size explanation करना है. So this is about actually what here exceptions in groups. Okay. So just I will remove this one. The red. You just take this from the textbook. Also, you can take this part and this part. Group 17 order, group 16 order. Okay. Take from the textbook also. You can. Now let me move to what next one. Now electron affinity of inert gases, group 18 elements are what? Zero. I told you just now, because of what? Stable electronic configuration. Because NS to NP6 is octet configuration. So they are stable configuration. Therefore, what happened? They do not undergo, isn't it, any type of addition of electrons. So zero group elements will have zero electron affinity. Group 18 will have zero electron affinity. Now in p-like elements, first electron affinity of third period elements is greater than corresponding second period element. Just now I told you, this one. Chlorine, which period actually? Third period. Chlorine, second period. You observe the value is 348, the value is 333. So just now we discussed this topic actually. What is the reason? Smaller the size of which atom? Fluorine. Strong inter-electron repulsions, where you get? In the fluorine. In the fluorine, because of small size, repulsions are more. Therefore, what happened? Fluorine is having less electron affinity. That is how much? 333. In chlorine, large size, presence of empty d orbital, the electron affinity values are more actually. Next. Now this is the order when you observe what happened. So whenever if you observe what happened, the 17th group elements are having what? High electron affinity values. And which group elements are having very less here? See this one. Which group elements these are? Zero group elements, isn't it? They are having something what? Zero group elements are there. Very lowest one you are getting. Zero group elements are getting very lowest one like this. So when you observe what happened, left to right, the electron affinity values increases and highest electron affinity values are having on which group elements? Which group elements are having highest electron affinity values? Which group elements are having highest electron affinity values, beta? Yeah?
17 group.
Group 17. Now answer this one. Electron affinity is always negative, always positive. First negative, second positive, first positive, second negative. Tell me which is correct one?
First negative, second positive.
Second is what? Positive.
Option C.
Right. Now can you say which is the correct order now here? Which option is correct one?
Sir, D.
D is the
D.
correct one. Right. Very good.
D, sir.
Zero.
Zero group
Zero.
negative or zero?
Say zero.
D.
They are having highest electron affinity values. Which group elements?
Halogen.
Halogens.
Halogen.
Halogens.
Now this is about the electron affinity. See what happened. Electronegativity now. How many are there in the class now?
0.
48
So
only.
including you 44.
46 only. Include my 2 will be there. No, 46 only. That means 50 members were absent today. Who are they? Let me see here first of all. Abhishek, Y, Anshu Yadav, Anuj, Anushka, Apurva, Adar, Atul, Ayush, Balmukund, Bharati, Chaitanya, Dhanishri, Deepta, Janyashri, Gulabi, Kalpesh, Manoj, Mayur, Ojas, Omkar, Patil, Samiksha, Pradmesh, Raghav, Rahul, Raj, Ramya, Riya, Rohit, Sahil, Kesarkar, Samruddhi, Sapna, Shishidhar, Srihari, Sneha, Snehaji and Sneha, yes. Sonali, Sumit, Suraj, Tejaswini, Triyambak, Umesh, Vaishnavi Jadhav, Vaishnavi Nichal, Vedant, Vishal, and Yash. So these are the presentees in the class. So when I put what happened, absent is no, you can't say what happened, sir, I am present, I am there. So whoever there now have read out, no, they are actually there. It will be recorded, okay? So you can't say what happened, sir, I have there at the class, I have listened the entire the class, you can't say no. Because I have read the names, right? Next we see the what? Electronegativity now. Let me see the electronegativity. Now, electronegativity is a concept actually. It's a concept. It does not have any values actually. Simple, a phenomena actually. Now, let me see electronegativity now. Already you know what is electron affinity. Okay. Now, if I say what happened, electron affinity like this, X, an element, taking one electron, converting into X minus, this is a gaseous atom. Now, this you are calling electron affinity. Now, what is electronegativity now? Now, if I write something like this, A and B. Now, A and B already they formed a bond. Here it is a neutral gas atom, correct or not? It's a neutral gaseous atom. It's a neutral gas atom. But here you have taken a chemical bond, you have taken a covalent bonded molecule, you have taken a covalent bonded molecule, you have taken. Now, what is happening? Now, for example, just imagine B is having more efficiency to take the electron, tendency to attract electron. B is having more electronegativity. Just imagine B is having more electronegativity. Now, what happens here? The bonding electrons are took by whom actually? B. The bonding electrons are took by whom actually? B like this. So, what we are going to get here? A plus and B minus. Now, because of more electronegativity of B, isn't it? It is attracting the electrons, isn't it? Which electron? Shared electron, both electrons. This one and these two electrons are taken by whom? B. For example, you take HCl is there. HCl have taken. Okay. Now H is having one electron and Cl is having one electron, and both are what are contributing equally and they're sharing also equally. But which is more electronegative? Generally, hydrogen and chlorine. Chlorine is having more electronegativity. Now the bonding electrons are took by whom actually? Chlorine. So we are going to get H plus and Cl minus. So this is called what? Electronegativity. The tendency to attract shared electrons towards itself is called what? Electronegativity. Very simple thing. The tendency to attract shared electrons towards itself is called what? Electronegativity. See, the chlorine is having more tendency to attract what happened? Bonding electrons, shared electrons towards it. So it is what? Electronegative. This will be electronegativity will be less here for this one. So this is the thing actually, the electronegativity. Now, unlike ionization enthalpy and electron gain enthalpy, it is not a measurable quantity. I told you, it's a phenomena. I told you. I just not tell you, no, it's not a quantity. There will be no values for this one. Only the phenomena. It's a tendency. Okay, in this we don't have any values. For ionization enthalpy, electron gain enthalpy, we are having some values will be there. Kilojoules per mole, like that we measure that. So you can measure करने के लिए कुछ भी नहीं रहता है, because it's a tendency, phenomena है ना. इसमें ऐसा तो आपको क्वेश्चन आ सकता है ऐसा. Which of the following are not having the units here? Yes, electronegativity is not having the units. फिर भी हमको values लेते हैं मगर units नहीं रहते, number रहते हैं मगर we don't have the units for this. Now electronegativity of elements are measured by, these are the scales actually. Three scales: Pauling scale, Mulliken scale, and Roche scale actually. So these are not in the syllabus, leave it this one. Just the measuring scales. Pauling scale actually, we don't need this one. This is a Pauling scale. In this case, what he said actually, he just arbitrarily means what happened without any reason. Given the what? Electronegativity of hydrogen 2.1. Okay, by using the hydrogen, he calculated the remaining one. For example, fluorine, the value is given what? 4.0 actually. Based upon which one? Hydrogen. So hydrogen is a standard for giving the electronegativities for various elements. So arbitrarily, the value of electronegativity for hydrogen assigned is how much here? 2.1 actually. So based on that scale, what happened? We will give remaining electronegativities. Next, what happened? Mulliken scale. How do we calculate the electronegativity by using Mulliken scale? Just by taking the average of ionization energy and electron affinity. So then we get the electronegativity. Take average values of IE values and electron affinity values. Now it is applicable for what? Like this. Covalent like this we can easily. This is a formula generally for calculating the electronegativity. For example, if the IP values and EA values are given EV. Actually, this formula, if you observe what happened, formula observe this what happened in the EV values, electrovolts, take 5.6. IP plus EA divided by 5.6, you can take like this. This is the formula. The values are given in terms of electrovolts. If they're given in terms of kilojoules, take 4544. Okay. One, if the IP values are given like 560, it's given something what 270 like that. Then what happened? You take here 544. If they given something about EVs, kilojoules like this, here it is a kilojoule. If they given EVs like 2.3 EV or 3.4 EV, if that given, you have to take 5.6, the denominator. These are the formulas. Calories like this, 123. This is the calories. This is in terms of electrovolts. This is in terms of what? Kilojoules per mole. This is in terms of what? Kilocalories. Does it have units? Electronegativity?
The option is correct.
Which
So
one?
D, no units.
D, no units. It does not have any units actually. Is the correct one?
All of the above.
All, sir.
Sir,
All. All.
It is applicable only for monovalent beta. Only for monovalent means what happened? For example, X, isn't it? Taking one electron into what? X minus. Only for one like this. That means we are, for example, I'm writing like this. X converting into X plus one electron. So ionization potential values, something what happened? Plus 346 kilojoules per mole. Okay. Now X adding one electron, converting into X minus, electron affinity value, something what a minus 240 kilojoules per mole actually. Now this is monovalent and this one also monovalent. Only first this type of reactions it will work on actually. Only for monovalent. Electronegativity of hydrogen atom is arbitrarily taken how much value beta?
2.1.
2.1, right?
2.1.
What is the trend in the electronegativity groups and the periods actually? In groups and period, what will be the trends? In groups, what happened? You see, same trend, whether in electron affinity or electronegativity, same trend we have to follow. Right, so there is no difference in that one because in both the case we are attracting electrons only, no. So that is the reason if you read what this electron affinity trend, that will be same for what? Electronegativity. So based upon that, in group electronegativity decreases top to bottom and electronegativity increases left to right in the period. Reasons are what? Same. Correct? You observe this one. Observe the values now. Group 17 values. How much values you are getting? You observe here. See, observe lithium is how much you are having? 1.0. Here it is. Decreasing or not? Yes, it is decreasing. Electronegativity values are in group. This is a group. Fluorine 4.0, 3.0, 2.8, 2.0. So in group top to bottom, in groups top to bottom, electronegativity values what happening? Decreasing. The reason is same. Effective nuclear charge is what? Decreasing. The same reason we are writing here. In period what happened? Increases here. Because of what effective nuclear charge, what happened here increases. So for electron affinity and electronegativity, the reasons you can say what same only, the effective nuclear charge only. Effective nuclear charge only, right? You take for an example, lithium, second period I have taken, second period, lithium 1.0, beryllium 1.5, boron 2.0, carbon 2.5, nitrogen 3.0, oxygen 3.5, and fluorine 4.0. In the third period, if you observe what happened, sodium 0.9, 1.2, 1.5, 1.2, 2.9, 2.5. It is increasing. So, what I mean to say, in a given period, always what happened, left to right, these values always what happened, increases. Which is having highest electronegativity? Halogens. Just like electron gain enthalpies, halogens are also having highest electronegativity values. Which is the most electronegative element? Fluorine. Its value is what here? 4.0. Its value is what here? 4.0. Which is the less electronegative element? Cesium. Cesium is the very less electronegative element here, right? So what are the factors affecting the electronegativity? These are the factors. Nature of the bond. If the bond is very strong, what happens? Generally, if you ionic bond, it will cleave like that here. Atomic size, already you know, more atomic size, less electronegative. More nuclear charge, what happens? More electron negativity actually. So inert gas elements, group 18 elements have zero electronegativity because they are having stable electronic configuration. Just like electron gain enthalpy, here also what? Same thing you are getting actually. Now let us see all the properties now, because the periodic properties now we completed. Atomic radius in group increases, in period decreases. Next, electropositivity in groups increases, in period decreases. Third one, metallic nature in group increases, in period decreases. Fourth one, basic nature of oxides increases, decreases in period actually. See. Fifth one, ionization potential decreases. Already we discussed this one, increases. Electronegativity in group decreases, in period increases here. Next, what happened? Electron gain enthalpy in group decreases, in group increases. So if you observe what happened here, non-metallic nature. If you observe what happened, all are having what same things, correct or not? All are having in all properties from 5 to what happened? 9. In group, all are decreasing. In period, all are increasing. What are they? Ionization potential, electronegativity, electron gain enthalpy. Now, non-metallic character. What is meaning of non-metallic character? Means attracting electrons. Non-metallic means what? Addition of electron, attracting electrons. Attracting of electrons can be done by whom actually? Electron gain enthalpy. That means electron gain enthalpy is more, non-metallic nature also will more. That is the reason both are having same things or not, isn't it? What is the meaning of non-metallic nature? Attracting of electron. What is the meaning of electron gain enthalpy? Attracting of electron. That means both are same or not? When they are both are same, what happens? Their values will be also same here. Now, what is the meaning of acidic nature of oxides? Also same thing. Acidic nature of oxide depends upon electronegativity. Okay. Higher the electronegativity, higher acidic character. For example, I will explain this one. You observe this one. I have taken this example here. Carbon dioxide. Okay. Next, what happened? I'm taking carbon, chlorine. Take what happened? Not carbon dioxide. You take this example. Chlorine, Cl2O7, and phosphorus, P2O5. Now, this is what actually less electronegative, and this one is what? More electronegative. Now, among these two, which is more acidic character? Cl2O7. Correct? Now, otherwise, we'll take what happened, one more, Cl2O7, Br2O3, something like this. Now, which is having more electronegativity? Chlorine. Therefore, this is what? More acidic character. So, higher the electronegativity, higher the acidic character. So, that is the reason So as electronegativity decreases in group, acidic nature also what? Decreases here. So in the previous one, if you observe what happened, the previous slide, if you observe what happened, they're all what? Same. This one if you observe. This one. Atomic radius, already you know this one. Electropositive character means what actually? What is the meaning of electropositive? Opposite to electronegativity. Opposite to electronegativity. Electropositive means losing of electron. Metallic nature means also what? Losing of electron. Now when you have more losing tendency, the basic nature also increases. For example, you take what happened? KOH. Okay? And what? Lithium OH. Rubidium OH. Cesium OH. And sodium hydroxide also you can take. Sodium OH. Now here, if you observe what happened, as top to bottom, isn't it? Metallic character will increases. Cesium will readily lose electron because of atomic size increasing. No, it will readily lose electron. So that is the reason what happened. It will have more basic character. So if you observe what happened, all these four. Metallic nature means losing of electron. Electropositive character means losing of electron. So there what happened? Increases in the period, decreases here. So there are what actually all these four having collectively what? Same type of order structure. It's already done. Most electronegative element in the periodic table is what? Which element is most?
Fluorine.
Fluorine.
Fluorine is the most electronegative. Electronegativity.
Fluorine.
Can you say the electronegativity order for this one?
Sir, C.
First fluorine,
Option C.
then oxygen, then,
C.
then carbon. Right. Very good. We answer 4 of them. About what actually? Electronegativity. This is what happened. We have completed the, isn't it? That electronegativities, and the last topic is there. The last topic is there. That is called some diagonal relationships and everything is there. Something. Last topics. Tomorrow I will complete this one. Here also you will get some questions in this topic. Trends in the chemical properties. This is the thing we are going to discuss tomorrow. Same time at 9 o'clock only start. Okay. So tomorrow we can finish this classification of elements. Tomorrow we can finish. And have you completed these topics? Yesterday, whichever I given, homework is completed. Complete tomorrow. Tomorrow I will give some more homework also, and by tomorrow entire exercise and everything I will give what to complete, and tomorrow we will finish the chapter also. This is about the today's class. If you have any doubts, stay with me, isn't it? Who joined now? The number is what increased 51 now. Recently who have joined now? Who joined recently? Again, I'm reading the names who are attending the class now. Abhishek Y, Akriti, Anshu Yadav, Anuj, Anushka, Apurva, Ashif, Adarva, Atul, Ayush, T, Balmukund, Bharati, Chaitanya, Dhanasri, Deepta, Rahul. Deepta, Rahul 2 नंबर है इसमें, 2 नंबर में ऐड है, इसका वजह से इसमें इंक्रीज हो गया शायद. ओके. धन्यश्री, गुलाबी, कल्पेश, कृणाल, मयूर, ओजस, ओमकार, पाटिल, समीक्षा, प्रथमेश, राघव, राहुल, राज, रम्या, रिया, रोहित, समृद्धि, शशि, शशिधर, श्रीहरि, स्नेहा जी, स्नेहा, बीएस, सोनाली, सुमित, तेजस्विनी, त्र्यंबक, उमेश, वैष्णवी जादव, वैष्णवी निचाल, वामन, वेदांत, विशाल and Yash. Total what happened? 48 students have joined today. If you have doubts, you can stay with me. Otherwise, what happened? You can log out.